Hi everybody, Ms. Lee here. In this video, we're going to talk a little bit about the significance of results. So we're going to first talk about a hypothesis. So a claim about a characteristic of a population is a hypothesis. So to analyze a hypothesis, you need to distinguish between results that can easily occur by chance and results that are highly unlikely to occur by chance. So just a reminder, mu is the mean for a population. So that will be used here and there. So just remember that. Okay, so for example, if you make a claim that you can make 80% of your basketball free throws, to test your claim, if you shoot 20 free throws and only make 8, that would seem very unlikely. So someone who makes 80% of their free throws probably rarely would ever make only 8 out of 20. So you might make an excuse and say oh, you're having a bad day, you're injured, or the ball is dead, or the hoop is bent, whatever. So all these are possibilities, but you want to think to yourself, well, how likely is this claim based on the probability that someone who really makes 80% would shoot 8 out of 20 on one trial run? So because that possibility or that probability is really, really low, that should be enough to know that that's a lie. So this is the basics of hypothesis testing. So an outcome that would rarely happen if a claim were true is pretty much good evidence that the claim is not true. So in this case, it was that someone stated that they could do 80% or they could shoot 80%. Then on a regular basis or a trial run or whatever, they should be getting something close to 80%. But being so far away from 80% is pretty unlikely if the 80% was true. And so therefore you can basically state that that hypothesis is not true. And so that's kind of how you want to deal with hypothesis testing. So that kind of brings us to what a null hypothesis is. So every randomized comparative experiment is to test a null hypothesis. So a null hypothesis states that any difference between the control group and the treatment group is due to chance. A statistical test will generally start with a careful statement of the claims we want to compare. Because the reasoning of tests look for evidence against a claim, we start with the claim we seek evidence against. So this is our null hypothesis. So things are happening as we expect, and there's a statement of no difference. That's what the null hypothesis is. So, for example, if we have 10 people with colds and are treated with a new formula for an existing brand of cold medicine, and 10 other people with colds are treated with the original formula, and the mean recovery times for the groups are compared, your null hypothesis would be that any difference between those two groups is just chance. So null hypothesis is the statistical occurrence where there is no real difference. Okay, so when there is a difference, then that is not the null hypothesis. So any difference between those two groups would be about similar. That's your null hypothesis. So just to reiterate one more time, your null hypothesis for this situation would be that the recovery times for the two groups is either about the same or any difference is just statistically not significant. So yeah, and so that's what hypotheses and null hypotheses are. So happy day.